Good morning, 10th grade. I wonder how you're doing this morning. How'd you make out yesterday? Are you burning a lot of midnight oil? Are you working hard? Are you able to complete your lessons? Yeah, text me and give me information, give me feedback, tell me slow down, speed up. Yeah, I might slow down just a little bit here because I'm looking at what we have left. We have one book left and we're winding down on this book. And so maybe the last 2 weeks or so we can take a little slower. I almost felt like that in book 3. Yeah, it's book 4. In book 3 we went too fast. Obviously some of you got lost. Or some of you floundered a little bit. And so this book seems to be a little smoother, at least on my part. I don't know about you. You don't call me, you don't text me, so I don't know where you're at. But today I'm ready to do lesson 31, or page 31, and I'm going to do two sections, 31 to 34, and then I'll move over and we'll do 34 to 38. And the first one is direct variations, or another way to say this is direct proportions. You've done proportions before. They come at it maybe from a little bit different angle, but not much different from last year. If you recall last year, the proportions we did, I think this is identical. They don't spend a lot of time on it. It's basically just review. Yeah, you can look at your examples on page 31. 32 is, I'll do the first one. It says this way: in a circle, the circumference and diameter vary directly. Without using a value of pi, find the diameter of a circle with the circumference of 154. When you know that in the second circle, the diameter is 14 and the circumference is 44. So over here you got 14 and 44, and then you want to know what's this other one. So what you're using is the first one to get your proportion. It's 154, and you don't know the top answer. Can you see that? It looks kind of pale in the thing. 154 is your bottom one. Over here, the direct variation is 14 and 44. So maybe it would help if you would put it exactly as give you an example. So this is the diameter here, and the circumference here. Maybe it helps to identify that. What you want to do is put them in direct proportions. So the diameter is unknown when the circumference is 154, but the diameter is 14 when it's here. So when you have it set up in this way of proportion, you just simply multiply 14 times 54 divided by 44. Okay? If you go, I'll get that answer here, 14 times 44, no, 154 times 14, clear. Get the right one, 154 times 14. You can push it in yours. That equals 2156. 2156. And now I divide that by 44. I hit division. 44 equals 49. This answer is 49. It's in direct proportion. Now just drop down to the very next one, and you have, if x varies directly as y, and x is 7.5 and y is 10, find what x is when y is 4. So I again set them x and y, and x is 7.5 and 10 is y. Now what's y? Whoa, why did I put y here? I should have put 4. Is that right? Or which one am I wanting? X varies directly with y's. X is 7.5. 10 is y when x and y is 4. Okay, now I have 4 here. Yeah, I was supposed to put 4 there. So, again, you will work the same way. It's directly proportioned. So the size of this one here varies directly with this one. So I'm making this one smaller than 10. This answer is going to be smaller. So I go 7.5 times 4. I don't even know what that is. Yeah, I will find out. 7.5 times 4 equals 30. And now I take 30. 7.5 times 4 is 30. And whoa, that's pretty easy. Divide it by 10. And that makes the top answer 3. Let me check that to be sure. That's right, 3. You work on those others. Watch out for sometimes it'll say square. On 3.4 you have a graph. You're going to make that graph. I will show you that later when we move over the direct graph in comparison with the inverse graph, direct variation. Number 36 is just simply a yes or a no answer. Don't guess it though. 37, next page is fairly simple. I will let you figure those out. The main thing is to set the problem up correctly. Put them directly in proportion. Oh, I did 310. I didn't even see that. Sorry. 310. Last one. The distance of a body falls from rest varies as the square of the time the body is falling. Wow, you don't want to fall. Okay, hang on. If you're up high. If a body falls 64 feet in 2 seconds, 64 feet in 2 seconds, how far will it fall in 7 seconds? I'm telling you, it's going fast. Now look right here, the way you set up. Watch out for this. You will. I think the example shows you this. And by the way, if you're looking at the example in the day's lesson, you check it out. But I think there's a mistake. I don't think they figured that correctly when they multiplied. What was it? 2,000. Yeah, it's a. Oh no, sorry. That's tomorrow's lesson where they made a mistake. I'll get to that in a minute. Sorry, I jumped ahead. Here, you got to get the square of 2, which is 2 times 2 is 4. Watch out for that. The square of 7 is 49. Okay? You're falling 7. Watch out for this because it asks the square of the distance. Now you're ready to figure 49 times 64. Okay? 49 times 64 equals 3,136. And you divide that answer by 4. Divided by 4. You have fallen in 7 seconds 784 feet. Okay? Hang on. You went for a ride in 7 seconds. And you see what it is, direct proportions. May I just repeat myself here? Direct proportions always, when you increase the number, the next one increases as well. It's just like direct proportion. So automatically, whenever I knew that at 4 feet I fell 64, if I increase that number to 49, or no, in seconds, when I increased that from 2 seconds to 7 seconds, I knew this number was going to increase. Okay? That's just the way it is. I mean, a direct always increases. So when you're figuring these problems, you should be able to get a little bit of an idea. Oh, I'm going to have a bigger number, or I'm going to have a smaller number. It's direct proportion. See here, you went from 10 to 4. So you knew that 3, your answer had to be smaller than 7. Because you dropped the big number to 4. Okay? Use your common sense or judgment. Let's move over. Okay, we're doing inverse. And inverse is just the opposite. It's just like flipped backwards. And it's always in proportion to each other. So I set this up the way they did it in the book. It's a little bit different than what you can do. You can use that proportion method, direct one. This here is probably a little safer, the way they explained it. Read your examples, but on page 36 at the top of the page, I think they misfigured. When they multiplied cross corner 2,000 times 16,000, no, 16 million, they didn't get the correct answer if I figured right. But maybe they figured different than I am, so I'm not going to argue with them the way they set it up. I love setting it up this way right here. If you have, I'm going to do 311 just right to start with. Let me just show you. when find x when y is 32. Given that x varies inversely, okay, it's not directly, not versely, inversely, as y, and that x equals 132 when y is 4. Okay, x and y, that's your proportion that you'll judge it off of. It is, I like to put x1, y1, x1, x2, y2, and so I use that there for my proportions. The ones that I have is 4 times 132. That's the variation I have. So it means the opposite. It's going to, as one gets bigger, the other will get smaller. So here, I have to multiply 4 times 132. Again, I'll do that on my calculator. 4 times 132 equals 528. This is 528. Okay, now let me tell you how I'm going a little quick here. Maybe I should enforce to you that over here you did not multiply them together, but the two ratios that you have, the two figures that you have that are setting your proportion, you multiply those together and divide it by the other. So if you set it up in an equation, it makes it easier to know what process to do. Over here, I put x here is 132, y here. On this side I got x and y again, so I put 32 and x is unknown. So I said this is 128, so if you want to do this here properly to isolate the x, you should divide 32 into it. And of course you'll know divide 32 into this one. You don't have to do all that, you can just go hit 528 divided by 32 equals 16.5. X equals 16.5. And I should check that to make sure that's correct. Yes, 3.11 is 16.5. 16 and a half. So that's the way you will do those. Let me talk about the graphs now. I'm not going to do any more on that, I don't think, unless you want me to. No, I'm going to let them go. 19 and 20. Oh yes, watch out for 15 to 18. You have to tell me if they're direct variation. They give you the problem. You say, is this direct proportional or is it an inverse proportional? So I'll do 3.18. Then the last one there for you. The number of tons of coal burned by an old coal burning locomotive under given conditions varies as the number of hours. Okay, so you're burning coal in this old locomotive, and the longer you burn it, the more coal it's going to take. Now, I gave you a few little hints there. So tell me, is this a direct proportion or an inverse proportion? Okay, to keep the fire going, you got to keep shoveling coal. So the longer you burn it, the higher the coal goes. Direct or indirect? Give me feedback. Text me quick. Oh no, don't text me now. I'm probably sleeping when you're doing this here. Direct. It's a direct proportion. As the hours increase, the coal increases, so it's direct. Now if the hours increase, it'd be reversed. So let's turn over here and look at 3.14 on your graph. Matter of fact is, you want to turn your book back. I will do 3.4 first. The graph 3.4. Okay, I'm using this whole board, but this here corner right here, turn around here so I can see you, or no, so you can see me. Wow, that's something way to say it. This here is your graph right here, and you're to use your other problem to figure out your graph. Maybe I should read it. Oh yeah, you're using the circle of the circumference, and you know that we figured that one out. It's 14 is 44. So what you know at 14, that's in this mark right here, and at 44 you come over, so you put a dot right here. At 14 and 44. And then we figured it out for 154. Whoa, I don't have quite 154. Your graph has got it. But at 154, we came over here to 49. So 154 is going to be up in here somewhere. I don't know where it's at. But I tell you how else you can figure it. You can figure that if 14 is 44, you know that 7 is 22. So you can drop him in. Or bigger yet, you know that if 28, if you go 28 you know that's going to be 88. So you're going to be at 88 and at 28. You're going to put a dot right there. You see how this line is going up on a slope? I'll guarantee you up here, when you get up here to 49 and 54, wherever this ended, it's going to continue right up through there. Okay, that's a direct proportion, you see? As this one increased, this one increased. Does that make sense? Direct proportions? It should. Matter of fact is, direct proportions are just simple. Just simple. They're nothing. Yeah, this should not be tough. Now let me talk about inverse proportions. Inverse is just a little bit different. I mean, a lot different. A lot different. Got it? As it increases, as a 1 increases, it goes down. Okay? So now let me show you how that would look on the graph. Can you see here? I'm going to use this part of the graph right here now. Okay, and I put it in green. And your graph isn't quite big enough. I don't know why. Now I'm going to, from 3.4, now I'm jumping over to 314. Okay, the graph on 314. It says, draw the graph representing the rates and times involved in going a distance of 36 miles. Use only the first quadrant. Okay. Now I am just a little bit confused. He went 36 miles, but what was the time? I wouldn't have known. You know, if it wouldn't have been for the answer book, I would not have known how to do this problem. Now, you probably did. You could think it through. I couldn't think it through. He went 36 miles, but what was the time? That was unknown to me. 36. Well, I could mark 36 on here, but I had no. I could mark 36 over there. I had no clue where it was supposed to go. Well, let me show you a little picture of what I draw to make this proportion. As this one increased, it was 1 hour. The time was 1 hour. The time was 1 hour. That's what the answer book says. And when you use 1 hour, it comes out, or you can make it, it makes sense. So the rate was 36 and 1 hour. And in time, proportion-wise, it went backwards. So when he increased to 2 hours, he only went 18. You see, it's inverse proportion. And then when he ran 3 hours, it was only 12. Okay, as this one increases, it goes backward. And then you got 4 hours, it's 9. You see proportion-wise how this is working? And then in 6 hours, it's 6. So there's half and half. In time-wise of 9 hours, it's 4. 18 hours, it's 2. 36 hours, it's 1. It's exactly backwards. As a 1 increases, the other one decreases. That's inverse proportions. See, this isn't as easy to comprehend in our minds as direct. As you direct it, you increase. Okay, inverse, you got to think backwards. And you say, oh my, this can't be possible. Well, yes, in different situations, especially if you are operating something, if you're figuring out how fast something is going, how slow something is going, if you're doing reduction on gears, you need this here inverse proportion. So, if I can pull you back just a little bit, you want to keep that there in view, that little chart there I got it. Well, I don't know if you can't get the chart and everything in, but this will work. Now, you have rate and time. So I'm going to put this here as a time down here. This is the time, and this is a rate up this way. R-A-T-E. Probably can't see it, it's probably off the thing. Yeah, you can see a little bit right there. Now, use this here chart over here to do the thing. So, let's see, the rate is 36 on this first one, the time is 1. So I come up here to 36, that's exactly at the top. They must have made this chart just, and I come over 1. Okay? Now, the next one is 18 and 2. Wow, look where that puts me. That puts me way down here, 20, 18, and I'm at 2. Okay? Now that I've got 18 and 2, I drop over, I got 12 and 3. Okay, I got 10, I'm at 12, and now I'm at 3. See how that's looking? Look what's happening. The next one is 9 and 4. So I'm at 1, 2, 3, 4. So I'm right there. 6 and 6. So I'm at 6 and 6. I'm right there. And I will let you continue finishing that. Your chart only goes to 24, so you'll have to phase out. Your chart only goes to 24 here, but you can get the 18, the 1, and the 36. You'll just have to phase that out up above your chart, or add to your chart, however you want to do it. And the same way down here at the bottom, my chart only went to 25. You'll have to, you got 18. I could have got 18, which I would have got down here at the bottom. I'd have been at 18 and 2. I can mark him, and then you can just phase this on out to there. You would draw your line. That gives you a perspective. Your example will show you that as well. But yeah, and that's all we'll do today. Well, I want you to finish on over to page 38. There is one problem on page 38. I want you to do 38, and then tomorrow we'll come back and finish that part. See you.